All right, here we go, kids. Lesson 5-3. I'm going to start a little song here as we begin this Poisson distribution. Maybe you recognize this if you're a fan of the 70s and Jim Croce and folk music. This is called Time in a Bottle. Song filled with angst. Oh, so sweet. We'll bring him down. So the main reason I'm bringing him into the picture is that today we can begin to work with time. How exciting. It becomes a variable. So Jim may have said, we're putting time in a bottle. Heck, we're putting time into an equation. Key ideas. You're going to calculate, interpret, and use Poisson distributions. And there's a formula that's going to help us get through these problems. Okay? Really specific unit. So, a discrete distribution that is applied over a specific interval is what we call a Poisson distribution. Now, it doesn't need to be time. We could be doing distance. You could be doing volume. You could be doing area. All sorts of different intervals that we could use besides time. So let's look at the formula. Here it is. A couple weird things. It requires that you know mu. So you got to know the mean ahead of time. It also uses, how exciting, e. You remember using e with logarithms and the natural log base? And then finally, there's a denominator of a factorial. A couple things about x that we should mention here. The number of occurrences, which is x, must be random. They must be independent of each other. That is, we cannot have one cause another one to occur. And they should be uniformly spread out. Now, it shouldn't be perfectly spread out, yes? But certainly relatively uniformly spread out. I forgot to add this part in. We can get the standard deviation in a Poisson distribution by taking the square root of mu. Here's an example. From 1960 to 2015, that was a span of 55 years. Okay, let me change my color here. So, we had 336 hurricanes in the Atlantic. So we're going to do three things. 1, find mu. 2, find the probability of 8 hurricanes. And then 3, we're going to compare that. So let's find mu first of all. To find the average, the mu in this case, we're going to take 336 divided by 55. So a real simple way to calculate mu. And here we have 6.1 hurricanes per year. Next, check, done. Now we come to find the probability of 8. So now we use the formula. So again, here is 6.1, the mu, carried to the number of occurrences I'm looking for, and then e to the negative mu, odd, and then divided by 8 factorial. And your calculator should tell you this is 0.107. And go ahead and make sure you can do that. Yeah, kind of important. Next, how does, if in the past, over the past 55 years, yeah, we had 5 different years that each had 8, right? And 8 is more than 6.1, right? So how does this compare? Well, when I took the probability of 8, I got 10.7. So if I take 55 years times 10.7 to see what proportion that is, that gives me 5.9 years. And as I compare 5.9 years to 5 years, why, that's pretty darn close. So this Poisson distribution was reasonable. Okay, it worked out. Now, the other thing we can do is we can use Poisson to approximate a binomial. Remember the binomial distributions that we did in 5.2? Kind of a complex procedure. So this Poisson is a little bit faster. Huh? The French, always looking for shortcuts. So we have to have two requirements. Number one, n should be greater than or equal to 100. All right, and then remember that the percentage of success times n should be greater than 10. If those two meet, then we can do this little shortcut. First of all, to get mu, we're going to take n times p. So in my example here, we're going to go to a slightly different, we're going to go to Maine, pick 4. It's a lottery game they play in Maine apparently. I've never been myself. I'm sure it's a great place, and I'm sure this is a great way to raise money for the state. So you pay 50 cents, and you pick a sequence of 4 digits, 0 to 9. Yeah? For example, you could pick 2471. If you play once a day, find the probability that you will win once in 365 days. All right? So here we go. We're going to, first of all, notice our n is bigger than 100. Why? Because n equals 365. Next, let's take n times p. All right, and n times p here, p is our probability of success. So let's figure out what is our probability of success in this case. Well, you have 1/10 chance of picking the first digit correct. You have 1/10 chance of picking the next and the following and so forth. And so we get 1/10,000, right? And if I take 1/10,000 times n, yeah, this is going to give me 365 over 10,000. And that certainly is bigger than 10. Sorry, less than. I had that down there incorrectly. Fix that, kids. Less than or equal to 10. Okay. Phew. Got scared there for a second. Okay, so that's less than or equal to 10. So now we can proceed with using this formula. To calculate mu, the average, we take n, 365, times 1 over 10,000, and that gives me 0.0365, which, if we think about it, is a 3.7% chance of us winning on average. All right? Next, I'm going to take, now that I found mu, I can come back and do the Poisson distribution. All right? And to do this then, we take our mu, and we're going to do what is the probability of 0. And what we'll do is once we get this probability of 0, we'll subtract that from 1, and then that will tell us what is the probability of winning at least once a year. All right? Okay, so the probability of 0 is going to be, I got to go back and look at the formula. We need mu to the x, so mu is 0.0365 carried to the x power, which is 0, times e to the negative mu, which is going to be negative 0.0365, all over 0 factorial. All right, well, a lot of this problem cleans up nicely because our denominator turns into 1. This piece carried to the 0 power turns into 1. So all I really need to do is go to my calculator, type in e to the negative 0.0365, and that should give you approximately 0.9642. All right, so you have a 96% chance of winning 0 times. So now if I go back and I say, okay, what is the probability of winning at least once? Then we would do 1 minus 0.9642, and that's going to give us 0.0358. Okay, so approximately a 3.6% chance that we will win at least once in a year. Not really good odds, but again, you're paying 50 cents a year for entertainment, so if that cranks your boat, then go ahead and do that. All right, good luck with your homework, and we're done with chapter 5.